Okay, welcome back. Happy Monday. Today, April 3rd, this is our review for test number 2. I announced to a couple of folks, but I'll announce to one more folk that the project is now going to be due on Wednesday, the start of Wednesday's test. So coming up on Wednesday's test number 2. So test number 2 is on all of this stuff. We're going to spend a few minutes today just kind of reviewing for test 2. But since we lost out on Friday's class because of snow, I thought we'd spend a few minutes today just kind of going over some of the stuff in the probability and economics section. So this is going to be like a just very brief highlights thing, and it assumes that you watched that video from a couple of years ago. So here's the first question. In the activities on page 78, it says you've got this PDF pictured here, and it has to do with tons of kelp eaten per day by a certain whale, and on the vertical is a fraction of days that the whale ate that kelp. And so, I do want to highlight that you do not have to do any slicing for probability formulas. Today we're just going to, for probability, you just get to use the magic integrals. It's one of the few places where you don't have to slice. Okay, so it says find the percentage of days where the whale ate between 7 and 8 tons. By the definition of a PDF, this kind of function right here, that percentage is exactly the area under the curve between 7 and 8. So this question just says find the area of that trapezoid. That is the definition of a PDF. It's the area under the curve between 2 points is exactly the same as the probability or percentage that the variable is in between those 2 points. Okay. So let's just do our quick calculation here. Integral from 7 to 8 of, I don't even know what it's called up there, we'll just call it PDF, equals, and it's a trapezoid, so half the height times the sum of the bases, 0.12 plus, what's the other one, 0.18? What do we get here? 30.15. Okay, so on 15% of all the days, this whale ate between 7 and 8 tons of kelp.
I mean, it has to be set up that way for you to be able to do that, though, right? Like, you can't just whether something other than percents on the y-axis.
No, it's got to be set up this way. Yep, it's the definition of a PDF. Also part of the definition of the PDF, if you take a look at the area under the whole thing, what do you have to get? Have to get 1 or 100%. Gotta be. Okay, I think that's good there. This one here says what's the probability that the whale will eat between 7 and 8 tons? It's the same, just a different way to say the same question. Percentage, probability, same thing. Okay, on the next page is our first magic integral formula. It says to find the median, means we're looking for the number that's in the middle, the median number of tons of kelp eaten per day. So if we're at the middle, that means that 50% of the days we're going to eat less than this number of tons of kelp, and 50% of the days we're going to eat more than this number of tons of kelp. So what we're looking for is the magic spot where the area to the left and to the right is both 50%, right? And so I'm someplace in between 2 and 8. What do you think? If I go there, area left and area right, do they look like they could be equal? Not so much. And we can try here maybe. Ish. Do you think we're past this spot? Like, is it over here somewhere? No. So I feel like pretty confidently I can say that it's someplace on this first line segment here. And so, so in order to find that magic spot, we just have to take the first line segment, which is given by 0.04x, that's up above, and then set up the integral from 0 to, let's just call it some magic number. We'll call it C. Probably not really close to where it is, maybe in here somewhere. Maybe somewhere there. So that the integral between 2 and C of the function is equal to what magic number? 0.5. That is what we want. We are going to force the C to make us have an area of 0.5. You could just as well do the area from C to where? Could do C to 8, but that's trickier because from C to 8, according to that diagram, involves both of these equations. So you really need to do two different integrals, right? You'd have to do C to 6 of the first equation plus 6 to 8 of the second equation. Totally fine, but I'd rather just do one integral instead of the two.
What if it's not obvious which line it is?
If it's not obvious, then you'd have to try, like we could try this. And if it turns out that C is equal to, let's say 7, then what does that say about my picture? It didn't work, right? There's going to be a C that's going to make this work. But if it happens that it isn't between 2 and 6, then I've made a bad assumption here, and then we'll fix it and work on the other line. Okay, so 0.04 x squared over 2 from 2 to C. Let's see, that's a 0.02 x squared from 2 to C. And then it's not so hard to finish. So it's a 0.02, plug in the C, and then plug in the 2, and make it equal to half. So that's a 4. 4 times 0.02 is 0.08. And then divide by the 0.02, and then take a square root. What do we get here? 50. Thank you. Good. So I'll repeat, you don't need to do any slicing. You don't need to build this formula. If I ask you a question like this on the test, you can just use the integral and set the thing equal to 0.5. Questions on that one? Okay, and then there was one more magic formula from this section from Friday's No Doubt class. They have what they need here. And it had to do with the mean of a population. And so I'm jumping 2 pages ahead now to this guy. So if I ask you a question about the mean on the test, you get to just use this formula. You don't need to build it, even though building it is exactly what you did on the previous page in this activity. So it says to calculate the mean, you just do the integral from minus infinity to infinity. That's like all the input values of x times the PDF. So if I want to find the mean number of tons of kelp eaten per day, it's equal to integral. Okay, so it's not really minus infinity to infinity because this thing only lives from 2 to 8. I'm just going to do this part, and you can do the other part separately. So this is 2 to 6. And the function says x times the PDF. What is the PDF from 2 to 6? 0.04x. I said you could do the other one separately. Let's just write it. The other function lives where? 6 to 8. And again, it's x times p of x. X times a different function. This is the bottom row. And that's it. 2 easy integrals, right? Just multiply the x into the parentheses, do your antiderivative, and plug in. And technically, this function does live beyond 2 to 6, or 2 to 8, I should say. Technically, it's going to be 0 out there and 0 out there. The whale never ate less than 2 tons of kelp and never ate more than 8 tons of kelp. So minus infinity to infinity still works. It's just that we've only written down the parts that aren't 0. Second, in the magic formula, it is an average, so we're not going to go through it, but if you haven't had a chance yet, you should run through this argument. There is a divide by the total number of people, but that isn't x. That's what we called n. Everything kind of works out that multiplying x by I mean, it's an area of a rectangle thing. That's why it's an x times p of x. Okay, any questions on any of the probability stuff? Okay, so let's move on to the review page, which is 84. Okay, 2 focuses on Wednesday's test. First one is about integrals. Trig substitution, we have not yet been tested on. That was not on the first test. It was a long time ago. So you're definitely going to see a trig sub. Now, in theory, you should be able to handle any of the antiderivative techniques we worked on the first test. That said, this test here is not trying to see if you are still awesome at like partial fractions and integration by parts. I think I made it clear that I think U substitution is a very powerful, very important integrating technique. You should expect that you're still going to see U substitutions on this test and the next test and the final exam. But I also think I made it clear that integration by parts and partial fractions are very specialized, very narrow integration techniques. I tested you on them. I can't say definitively you're not going to see them again this semester, but that's not the goal of this test right here, okay? So make sure you can still do U substitutions, super, super important. But in terms of the more complicated integration techniques, trig sub is the only one that you're really responsible for at this moment. Okay, we also talked about doing integrals numerically. That was with like left rectangles, right rectangles, midpoints, trapezoids, and Simpson's rule. Improper integrals. Remember, this is the kind of thing where we have infinities and we change the infinities to a b, and we take a limit and we do all that stuff. And then the comparison test, where we use one of our useful integrals for comparison and try to decide whether our given integral converges or diverges. Okay, and then we have lots of applications of integrals. So we did a bunch of things by volume. This word slicing here, I'm going to cross that off because slicing actually applied to just about everything we did in terms of applications. It wasn't specific to integrals. We did volumes by disks, volumes by washers, volumes by shells, and volumes by known cross-section. Remember the funky shape where the cross-sections perpendicular to the x-axis were squares? Remember I showed you that kind of weird animation? So that's what we mean by known cross-sections. I'm going to put one more geometry application here. We also did arc length. Then we did 2 days on physics, density, and work. We did 1 day on economics, present and future value. And then Friday's Miss class was on probability density functions, and cumulative distribution functions. Okay, so to be clear, in terms of the slicing stuff, there are only 2 kinds of problems where you can use a magic integral and not demonstrate your understanding of slicing. Arc length and probability. On any other application of the integral, you should expect to have to build the integral by using slicing and a Riemann sum and a limit and all that jazz. The instructions on the test will make very clear, hey, don't use a magic formula here, or hey, it's okay to use a magic formula here. But I'm just trying to be upfront with you. Those are the only 2 places where you can expect to just use a magic formula. Okay, as usual, you can use a one-page reference sheet front and back. You can write anything you want on it, but it should be something you create and not a photocopy of something I gave you or something you found online or in your book. I'll lend you a scientific calculator on the test. If you don't have one, you cannot use a graphing calculator. The test is intended to be 1 hour, but everybody can have 2 as long as you're willing to get up early. 8 a.m. to 10 a.m. is our window. So show up at 8 if you want extra time. All right, I encourage you to show all work. As usual, don't leave anything blank. Any general questions before you spend the rest of the period just reviewing however you see fit? Okay, good. I'll walk around and check homework and answer questions that you have.